Alright everybody, what's going on? This video we're going to look at cylinders and quadric surfaces. Now before we get started, I'm going to give you a fair warning. I am not good at drawing these things at all. So I'll do the best I can. Hopefully you'll get to see a good picture of it. Alright, so let's go ahead and get started. So it says, in order to sketch the graph of a surface, it is useful to determine the curves of intersection of the surface with the planes parallel to the coordinate planes. These curves are called traces of the surface or cross sections. Okay, I'll talk about that more and explain it more when we get to doing the examples. And then we have a cylinder is a surface that consists of all lines called rulings that are parallel to a given line and pass through a given plane curve. And I'll show you what those are when we're working the problems also. All right, so let's go ahead and get started. So sketch the graph of the surface z equals x squared. All right, so we notice here that there's no y value, okay? There's no y value. And what this means is y is arbitrary. It can take on all values, okay? It can take on all values. And z equals x squared, that's what? That's a parabola, okay? And it's going to be a parabola in the xz plane. Okay. All right. So let's look at it. So we've got. Let's see. Let's draw our y-axis. Here's our x-axis. And here's our z-axis. And we'll go ahead and continue. Let's go ahead and continue the y-axis on this way. Now, this is a parabola in the xz plane. So we've got x, y, and z. And what this is going to do, see, y can take on any values, so it's like it's going to be an infinite number of parabolas along the y-axis. So you know, if we draw the parabola in the xz plane, it's going to look something like this. Okay, so it's kind of like if you're standing over here looking this way. Okay, standing over here on the y-axis looking this way, you would see the parabola. Okay, and so, and then you know, you would have another one maybe right here. All right, and then you know, you can have another one back here. And it's these parabolas, and they're going to meet right here. And actually this would be a solid line here and here. And then you got the dotted line because it's behind this thing right here. And so these parabolas here, that's what's called your traces. See, the traces are the cross section of the graph. And then the rulings are these lines here. You can, that's not a very good line. It's these lines here, and they're parallel to the y-axis. And these are your rulings that kind of, you know, fill in the shape of the, kind of get a little surface there or something. So, you know, the graph would look something like that right there. And this is called a parabolic cylinder. Okay, and and the thing here, this right here, this z equals x squared, these are parabolas in the xz plane. All right. We noticed the y terms missing, and this is called a cylinder. And I know it doesn't look like a cylinder like you would think, but when you're graphing these, when you're dealing with these, if one of the variables is missing, it's a cylinder. Okay. Now, what I've done, since I'm not the best at drawing these things, I actually graphed it on some software. And so this is what the graph would actually look like, is this right here. Okay, that's what the graph would look like. You can see you see the parabola right here. Okay, and it's just an infinite number of parabolas here, and it's going along they're going along the y-axis. Now, keep in mind also, it keeps going in this direction forever, and it's going in this direction forever also. Okay, it just keeps going. All right, but that's the graph of the first one. All right, now let's look at the next one. So we've got x squared plus y squared equals 1. Now, notice there's no z term. It doesn't include z. So z assumes all real values. All right. Now, what is this graph going to look like? All right. So, well, let's draw our x and y axis. So here's the y, here's your x, and there's your z. All right, so there's x, y, and z. Now, what is this? Well, this is a x squared plus y squared equals 1. That's a circle. All right, so we know this is going to be this x squared plus y squared equals 1, this is going to be a circle in the xy plane. All right, and what's the surface going to be called? Well, let's look. But these are your traces right here, circles in the xy plane. All right, so z can take on any value. So, that's like we can say z takes on any value. Z equals some number k. Okay, it's just going to go up and down. So if we look at the graph, well, it's basically a circle with radius 1, right? That's what this is. So if we come 1 unit, 1 unit, so it's going to look something like, and that's your circle right there. And actually, I need to, it's actually going to be dotted back there because we won't be able to see that. Okay. Now, that's the circle on the xy plane, but there's also going to be another circle, if I can draw that good, right here, and it continues like this. Okay, that's a cylinder, and you can have another circle down here, and it could continue on. And let me erase this. I told you I'm not good at drawing these things at all. It'll look something like that. Okay, and this is called a circular cylinder. All right, and I'll show you in a minute what the graph actually looks like. And this is pretty close. And then your rulings would look like this. See that? Something like this. All right, and that's your graph. So you know these first ones, they're pretty easy. Okay, they're not bad at all. All right, and then the graph is going to look like this. There's your graph right there. That's what it would, you know, a good picture of it. All right. So you know, so far these are pretty easy. They're not too bad. All right, so that was x squared plus y squared equals 1. Now, let's look at this next example. We've got y squared plus z squared equals 1. Okay, it doesn't, this graph doesn't include an x. Okay, it doesn't have an x value, so x assumes all real values. Okay, and this is going to consist of lines parallel to the x-axis passing through this graph right here. You know, talking about your rulings. All right. So when we look at this, what are the traces? The traces, these are what? These are circles in what? In the YZ plane. Okay. See, this is just a circle in the YZ plane. All right, so let's go ahead and graph this thing. All right, there's X, Y, and Z. So this is a circle with radius 1, okay? And so there's 1, 1, whoop, let's see. Hang on. All right, so it's in the YZ plane, right? The YZ plane. So we've got 1, 1, 1, and 1. And so it's going to look something like, I don't know if I'm something like this. And then you could have another one like this. Okay, in the YZ plane. All right, so think about it this way. All right, you understand that this part right here, see, this is your YZ plane right here. Okay, it's like you're standing over here and looking back that way. That's your YZ plane. All right, so this graph, or this, let me change colors back. It's going to look something like this. Okay, and actually I need to erase this. This is going to be a dotted line right here. Okay, and you know, and once again, keep in mind this thing's continuing this way and this way forever. Okay, it's continuing that way, and then you know you've got your rulings here, and so it'll look something like this. And this surface here is called, or this cylinder is a circular cylinder. All right. So you know it's important. It's important to know what the traces are. You know, you need to know what the traces are. What's that graph, and in what plane is it? Okay, and then identifying the surface, what kind of surface it is. Okay, and then the actual graph of it, it is going to look something like that right there. Okay, all right, so there you go. So far, so good. To me, I think the cylinders, they're the easiest ones to graph. When we got that variable missing, it's not much to it. All right, so now let's look at the next thing, at quadric surfaces. So it says a quadric surface is the graph of a second degree equation in three variables x, y, and z. The most general such equation is this thing right here. Okay, I'm not going to read it all off. You can read that, where a, b, c all the way to j are constants. But by translation and rotation, it can be brought into one of two standard forms. We could actually write all this as either this or this, ax squared plus by squared plus cz squared plus j equals 0, or ax squared plus by squared plus cz squared equals 0. All right, so let's look at this this example here. I know it's number 4. We're going to sketch the surface. It's the same direction as the first 3, but we're going to sketch the surface. So one thing we're going to do here is let's find the intercepts. Okay, let's find the intercepts where it crosses the axes. So what I can do there is I can set x equal to 0, I set y equal to 0, and I can set z equal to 0. Okay, so let's see what happens when we do that. So the first thing, if I set z equal to 0, that's going to give me what? X squared. That's going to give me x squared plus y squared over 9 equals 1. All right. Now, let's think about what that is. That's an ellipse, right? Now, one thing that you've got to understand about this section here is you've got to know how to do the conic sections. Okay, that's back from when you did conic sections. I can't remember exactly what section it was. I think in the Stewart book at the time of this recording, I think it's section 10.5. But that's conic sections. But whatever book you have, whatever section it is, if you're not good with conic sections, you need to go back and look at them again. All right. So this right here gives intercepts. Okay, it's going to give us intercepts at where? Well, A is plus or minus 1, right? And B is what? Well, B is 3, A is 1. So we're going to have intercepts at plus or minus 1, 0, 0. That's on your x-axis, right? And on your y-axis, it's going to cross at plus and minus 3. Remember, this is an ellipse in which plane? In the xy plane. So for this intercept on the y-axis, that's going to be 0 plus or minus 3, 0. So that's when z equals 0. And then we've got, let's do y equals 0. And so that's going to leave us with x squared plus z squared over 4 equals 1. And this is going to give intercepts where? Well, at plus minus 1. Okay, see there? For the x. And then it's going to intersect the z-axis. That's going to be what? 0, 0, plus or minus 2. So let's just make a note here that for this one, this first one here, this is going to be this one right here. I'll just kind of, that's an ellipse in the what? In the XY plane. Okay, the trace is going to be an ellipse in the XY plane. And what about for this second one? What's the trace going to be? It's going to be an ellipse in which plane? In the XZ Z plane. Okay, and then we'll put x equal to 0. Well, that's going to leave us with what? Y squared over 9 plus z squared over 4 equals 1. And this is going to give us intercepts where? At 0 plus or minus 3, 0, and what? 0, 0 plus or minus 2. Now, what about the traces for this one? Well, these are going to be, this is going to be an ellipse in which plane? In the YZ plane. Okay, so I hope everybody sees that. Now just make sure that you know how to identify these traces, what they are and what plane they're in. Okay, that's your cross section or your trace. All right, so let's go ahead and graph this thing. All right. So what I would do here is just let's just start with this z equals 0, and you've got your intercepts here at plus minus 1, 0, 0, and 0 plus minus 3, 0. So let's go ahead and make our tick marks here. So we got 1, 2, 3, 1, 2, 3, 1, 2, 3. And then let's come up here. All right. So let's mark these points here. Okay. So that's plus or minus 1. That's here and here. And then I've got 0 plus minus 3, 0. That's here and here. And so what we have here is we can draw our ellipse. See that? Draw our ellipse. And then this one that's going to come back here, that'll be hidden. We won't be able to see that. Okay, so that's this one right here. All right, now what about when y is 0? That's an ellipse in the xz plane, and that's going to contain 1 plus or minus 1, 0, 0, and 0, 0 plus or minus 2. That's the intercepts. All right, so let's plot the points. 0, 0, 0 plus or minus 2. That would be these right here. Okay, we've already got this one plotted. All right, and so this graph is going to look like this. It's going to come like this, and then this back here, that'll be hidden there. So you can kind of see how the ellipse is coming together. Okay, and then for x equals 0, well, that's an ellipse in the YZ plane, and you can see here's the intercepts right here. So this one and this one, we've got them both plotted. So that's going to be an ellipse that comes like this. Okay, and so that ellipse is going to be like this. And you can see how it's coming together. It kind of looks three-dimensional. Okay, we got x, there's y, and there's z. And so this is your graph, and this is called an ellipsoid. Okay, it's called an ellipsoid. And the traces are parabolas. Okay, and like I said, make sure you can tell what the traces are and what plane they're in. Okay, and so once again I've got a graph, and that's what the graph looks like. Whoop, get it off of that. Move it down there, and so there's your graph right there. You see it? No, doesn't look too bad, does it? All right. moving right along. Let's see what we've got here on the next problem. Okay, so here we've got 4x squared plus y squared, or z equals 4x squared plus y squared. All right, so how about graphing these? All right, so let's go through and see what happens with x, y, and z. Okay, so x equals 0. That means we're going to have what? Z equals y squared. Okay, and I can let x equal k, where it can take on any value. Okay, and look, I could do the same thing up here also, letting x, y, and z take on a value of k, and all that's doing. So, you know, for instance, let's say maybe look at this one right here. This one right here, the one that's in the xz plane, this ellipse right here. See, if y was k, then I would have this. I would have x squared plus z squared over 4 equals 1 minus k squared over 4 if y was k, where k is a constant. And so, you know, we're moving that over. Well, what that's going to do is it's going to create it'll create another ellipse like down here. And see, it's an infinite number of ellipses, you know, like this. That's what it's going to do. But on this one, we could actually get the graph and everything, you know. Without doing that, it gave us a good representation of the graph there. But on this one, let's look. So if x is k, then that's going to give me what? Z is equal to y squared plus 4k squared. Okay, I'm replacing the x with a k. All right, so what is this actually giving us here? Okay, so what are the traces? Well, the traces are parabolas. Okay, parabolas in which plane? In the YZ plane. See, we've got our x terms missing. All right, and then let's do y equals 0, which that's going to give us z is equal to what? Is equal to 4x squared. That's when y is 0. And then if we let y take on any value k, then I get z is equal to 4x squared plus k squared. And remember, k is a constant. And these, what are these traces? Well, these are parabolas in which plane? In the xz plane. All right. And then what happens if I let z take on any constant value? Well, that's going to give me what? That's going to give me 4x squared plus y squared equals k. Okay, so what is this? Well, this is what? This is an ellipse, right? I can divide by k to get a 1 over here. And so this is an ellipse, or the trace is an ellipse in which plane? In the xy plane. All right. And also here, keep in mind that k is positive. We can't, because we're not going to have this equals a negative number. Okay, well, for one thing, it'll never equal a negative number, will it? Okay, so just keep in mind k is positive. All right, so let's see if somehow we can draw this thing. All right, so let's look at this. All right, so let's draw it. There's X, Y, and Z. All right, so if I'm looking at this, when X is 0, I have Z equals Y squared. So this is a parabola. Okay, this is a parabola in the YZ plane. Okay, in the YZ plane. So what's the YZ plane? Well, that's if I'm standing over here. If I'm standing over here looking back this way, this plane here, this right here, it's that part. That's your YZ plane. So I've got to draw a parabola that's in that plane. And so it's gonna look something. Let me go back. Let me change the colors. So it's gonna look something like this. I don't know how good I'm gonna be able to draw this, but something like that. There's your parabola. Okay. And I'll show you in a minute about the other parabolas too, where we have X equal K, Y equal K, that stuff. All right. Let me extend this on. All right. Now let's look at this one. When we've got Y equals 0, we've got a parabola. We got Z equals 4x squared. We got a parabola in the XZ plane. Okay, so let's draw our trace. So that's going to look something like this. And then it's going to come this way. And this is going to be dotted. Okay. So there's that one. Now, the next one, Z equals K. This is an ellipse in the XY plane. So it's going to look. All right, so let's see. Hopefully I don't butcher this too bad. It's going to look something like that. All right. And you can see, and of course this will come on that way, and then that's dotted right there. All right. So this is your parabola, okay? And you can see here, let's just look at this Y equals 0, and then we got Y equals K. That's going to be where K is a real number, so we've got 4x squared plus K squared. So what it is, and I'm going to try to draw this the best I can, but it's going to look something, it would be like a parabola, maybe like this. You'd have a parabola down here like that, something like that. Okay, I know that's terrible drawing, but that's what it is. Okay, but there's your graph. So we know what the traces are. We know what planes they're in. We identified all that up here. Now, what is this called here? Well, this is an elliptic paraboloid. All right. I hope you're really understanding how to identify all this stuff. Okay. All right. So let's see what that graph actually looks like. There it is. Okay. Yeah, I know mine looks a lot wider, doesn't it? But anyway, you get the idea. Okay. That's just something I've never really been that good at, is graphing these things. Not good at drawing either. All right, so let's look at this one. All right, so this one ought to be fun here. All right, so let's go through and see what we've got here. So, I could start off Z equals 0. Okay. And if that's the case, that's going to give me what? 0 is equal to x squared minus y squared over 4, which that is actually y equals plus or minus 2x. That's just a line, isn't it? Okay, that's a line in the xy plane. All right. Now, what if z is equal to k? Well, that's going to leave me with what? X squared minus y squared over 4 equals some number k. All right, now let's think about what this is. Think about it for just a minute. This is a hyperbola, right? This is a hyperbola. Now, there's something else that we need to look at too. So for this, okay, if k is positive, okay, so k is positive, the axis of the hyperbola is parallel to the x-axis. Okay, the axis of the hyperbola is parallel to the x-axis. And then if k is negative, the axis of the hyperbola is parallel to the y-axis. Okay. All right. So just think about that for just a second. So if k is positive, this is what we would have right here. But if k is negative, so let's suppose k is negative, so it's a negative number. So we've got x squared minus y squared over 4 equals k, and k is less than 0. So we have to make, we want to make k positive, right? So how would we make k positive? We would multiply by negative, right? A -1. So that would leave me with negative k, right? Now remember, this term right here is positive because k is negative. So if k is negative, a negative and a negative make a positive. And that would leave me with negative x squared plus y squared over 4, which is y squared over 4 minus x squared equals negative k. You see what that does? So you need to look at both of those right there. Okay, and like I said, if you're not good on the conic sections, you really need to go back and look at them. All right. So now, what if I have x equal k? K takes on any value. Well, that's going to leave me with what? Z equals negative y squared over 4 plus k squared. All right, so when when x is a value, I get this. So what's the trace? Okay, what's the trace? So the trace is a parabola that opens which way? Down, right? Because we have a negative in front. Opens down in which plane? In the YZ plane. All right. And then for y equal k, that's going to give me z equals x squared minus k squared over 4. And this is what? This is a parabola that opens up in the xz plane. All right. All right, so let's see what we can do here. Let's look at graphing this thing. So this graph, I'm not going to be too good at graphing this one, I don't think, but we'll see how it goes. All right, so let's All right, so let's look at this. We've got the axis of the hyperbola is parallel to the x-axis, and axis of the hyperbola is parallel to the y-axis. All right, so we're going to have, it's going to be something like this, and then we'll have one over here. See those, how they're, see the axis is parallel to the x-axis, and then we're going to have one where the axis is parallel to the y-axis. Okay, so let's see how this goes. So it'll look something like, maybe like this, and then we'll have another one. I don't know. Oh, like I told you, I'm not very good at these. Let me kind of move this over a little bit. All right, maybe something like that. Okay. Yes, I know it doesn't look that good, does it? All right, and so that takes care of our hyperbolas there. And I'll draw this and fill it in just a minute. But let's look at this. X equal k. So that's a parabola that opens down, and it's in the YZ plane. So remember, all right, there's X, there's Y, there's Z. It's in the YZ plane. It's a parabola that opens downward. So that's like if I'm standing over here looking back this way, I'm looking at this plane right here. Okay, so it'll look something like, let's see, maybe something like this, and then, okay, something like that right there. And then I have, excuse me, and then I have y equals k. So that's a parabola that opens up in the XZ plane. And so that's going to be, that'll be a parabola like this. Whoop. It'll look something like that. Okay. So there you have it. So now what we need to do here is kind of maybe fill this in a little bit. So it'll come down here like this, and let's see, we got this is gonna be, let's see, let's come down here like that. Yeah, terrible drawing. So something like this, and then we'll go up here like this, and then we've got this. And it kind of looks like a saddle there, doesn't it? You see that? Yeah, I know it's not very good, but there's the graph. Okay, there's your graph. Okay, so we know what all the traces were, what plane they're in, and this surface is a hyperbolic paraboloid. And this graph, it looks something like this. There you go. That's what it should look like. I know mine looks sad. Yeah, and you know, and I see my x-axis is going straight out this way, and the y-axis is kind of coming at you like this. So it's kind of like you're, I don't know, it's kind of rotated that way a little bit, and looking through here at it. Okay, but anyway, I warned you when we first started, I'm not good at drawing these things. So, all right, so let's look at this one. All right, so let's take a look at this. So let's look at z equals k. Okay, z equals k. that's going to give us x squared over 4 plus y squared over 9 is equal to 1 plus k squared. Okay? Equals 1 plus k squared. Now, you know, I mean, k can be 0, and you would have this equals 1. Okay? It would equal 1. All right. Now, I'm gonna talk about this one a little bit more. Okay? I'm gonna write something down, and then I will explain it to you. Once we graph it, I'll explain that what I have written down over here. Okay? So these are ellipses. These are ellipses in the xy plane. There's our traces, right? Now, as the absolute value of k increases, the ellipses get larger. I'll explain that in a minute. Okay. The smallest ellipse is when we have x squared over 4 plus y squared over 9 equals 1. In other words, when k equals 0. That's when we have our smallest ellipse. And I'll explain that in just a minute. I will look at that in a little more detail. Now, what if I have y equals 0? Okay. So if y equals 0, I get what? I get x squared over 4 minus z squared equals 1. All right. So what is this trace? This is a hyperbola in the xz plane. See, all we're doing here, we're just getting these traces and then drawing a picture from that. Okay, it gives us an idea of what the shape looks like. And then if I have x equals 0, that's going to leave me with what? Y squared minus 9 minus z squared equals 1. And what is this? Well, this is a hyperbola also. In which plane? In the YZ plane. All right. All right. So there you have it. So, you know, at this point, hopefully you can identify your traces. You can tell me what plane they're in. Okay. All right. So let's look at this graph. And so let's draw our x-axis, our y-axis, z-axis. Let's come on down, go this way, go this way. There's x, y, and z. Okay, so let's look. I don't know which ones do we want to draw first. I don't know. How about, I guess we can draw the I guess we can maybe draw the ellipses first. I don't know. It doesn't matter. All right. So it's an ellipse. Now we know the smallest ellipse is this one. So this is just centered at the 0, 0, 0, 0. Okay. It's on the XY plane. It's in the XY plane. And we can see it's going to be, it's going to be what? On the x-axis, we're going to go 2 in the positive, 2 in the negative. On the y-axis, we're going to go 3 in the positive, 3 in the negative. Okay, so I'm just going to kind of sketch that in right here. It'll look something like maybe something like that. That's not very good, is it? Let's see. How about, let's see, maybe we, like that. That looks a little flatter. All right, so that's the smallest. That's the smallest ellipse. Now, let's talk about this as the absolute value of x increases, the ellipses get larger. Okay, so not, I don't know, did I say x? I meant k if I said x. So as the absolute value of k increases, the ellipses get larger. So let's just think about this. Okay, so when k is 0, we've got a 1 here. But let's just say k gets larger and larger. Let's say, I don't know, maybe, I don't know, say 5. Say k is 5, so that's 25. So this would be 26 over here. And so then you've got x squared plus y squared over, and then this is going to be, that'd be what, 4 times 26? This would be 104 under here. And then 9 times 26, that would be 234 under here, right? Equals 1. Okay, so let's just say k was 5, so that means this side would be 26. So I would divide everything by that. And so now look at your A and B. See how your A and B is larger? So that ellipse is going to be larger. Okay, that's what it's talking about there. And so, you know, if we came up here, I mean, we would have an ellipse, you know, it would be larger like this. And same thing down here, it would, terrible drawing. But anyway, it would look something like, well, okay, so there's those. Now, let's look at this. I was getting ahead of myself. So here we've got a hyperbola in the XZ plane. Well, let's see, I don't know. Would it be easier XZ or XY plane? I guess we'll draw ellipse in the XZ plane. So, you know, you're looking at something like this, not ellipse. Did I say ellipse? I meant hyperbola. So it would be something like this in the XZ plane. Okay, and then, you know, if you drew it in the XY plane, that's like standing over here looking back this way. So, you know, I don't know, you maybe something like this. I don't know, something like that. Okay. Whoop. No, actually this would be hidden up into here like this. Okay, and it just kind of goes off like that. And now this, I need to redraw that, don't I? That's going to be like this and like this, and then this needs to be redrawn. Maybe something like this. Yeah, I know it's bad. And actually, this thing right here ought to be tilted back that way some. I don't know how I got it tilted like this. It should be more upright like that. But anyway, you get the idea. All right. And so now let's really look and see what it looks like. Now I will say this. I don't know what happened on this graph when I graphed it, but I could not get it to do right. But there you go. This right here, this, for some reason the software wouldn't pick it up. These are ellipses up here. I guess I couldn't, and down here also, you know, those are ellipses. And you can see the ellipse right there in the center. But for some reason I couldn't get the parameters of the calculator to make it look like an ellipse up here and down here. But that's what it should be, that. But that's something about what it looks like. All right. Okay, so now I think we're almost finished, but let's look at this right here. So what do we have here? So here we have the 6 basic types of quadric surfaces in standard form. Okay. Now, you've got an ellipsoid, an elliptic paraboloid, a hyperbolic paraboloid, a a cone, hyperboloid of one sheet. And actually, that's what this graph up here is. This graph up here is a hyperboloid of one sheet. Okay, that's what that one is. And then you have a hyperboloid of two sheets. So the main thing here, all right, so of course if you have the x squared, y squared, z squared, and they're all over a squared, b squared, c squared equals 1, well, all traces are ellipses. We graphed a problem like this, right? And if a, b, and c are equal, then the ellipsoid is a sphere. So let's look at this one. We've got z over c equals x squared over a squared plus y squared over b squared. Horizontal traces are ellipses. Vertical traces are parabolas. Okay, which, you know, I mean, yeah, it's nice. It's nice to remember that, but it's also good to be able, okay, z equal k, x equal k, y equal k. I can identify the traces from that. Or do you want to go through and memorize this chart? Now, don't get me wrong. It's good to know this and be able to match these with the figures, okay? And it says the variable raised to the first power indicates the axis of the paraboloid. So in other words, if we were, if say these variables can switch up, we can have x over here and a z squared over here, or a y over here and a z squared over here. So in other words, if it was the x, then it would, you know, it would be on over here like this. Okay? And then if the y were over here, then it would be like something like this. That's what they're talking about. So, you know, be able to switch that stuff up also. And then we've got z over c equals x squared over a squared minus y squared over b squared. Well, this is one we just graphed. Horizontal traces are hyperbolas, vertical traces are parabolas. But, you know, it's like I showed you earlier. I showed you a while ago in that example when we graphed this, you know, how we identified what our traces were. And then here, and this is a hyperbolic paraboloid, this is an elliptic paraboloid, and then we've got a cone. We didn't do an example of this, but horizontal traces are ellipses. You can see your ellipses right here. Vertical traces in the planes x equal k and y equal k are hyperbolas if k does not equal 0, but are pairs of lines if k equals 0. Okay, and you know, you can see that. I don't know if you can. I don't know if I can. Let me zoom in. You see the line right here and the line right here, and then you see these hyperbolas right here. That's what they're looking at there. And then a hyperboloid of one sheet. Well, we just did that one. Okay, and look, make sure you note this. Notice how only the z has a minus on it. So we got horizontal traces are ellipses, vertical traces are hyperbolas. Okay, we went through all that. That's fine. Now, it says the axis of symmetry. Okay, so notice the minus here. That's running this way. The axis of symmetry corresponds to the variable whose coefficient is negative. So if the y was negative and this were positive, the z was positive, the y was negative, it would run along this way. Okay, this would be tilted over like this. And then if it was the negative in front of the x, it would be running along this way. And then we have a hyperboloid of two sheets. We've got, notice how the negatives are in front of the x and the y, and the pluses in front of the z. So horizontal traces in z equal k, or ellipses if k is positive than c, or if k is greater than c, or k is less than negative c. The horizontal traces and z equal k are ellipses. And then we've got vertical traces or hyperbolas. The two minus signs indicate the two sheets. And so it's going to depend where are the minus signs. And that's actually what we're fixing to do. We're fixing to graph one of these, and we're not gonna really get into the detail that we did with the other ones. We're gonna just kind of go based on knowing this right here. Okay. And this is the last example. All right. So we can see this is a hyperboloid of two sheets. Okay. This is a hyperboloid. Of two sheets. Okay. But it's a little different than this one up here, isn't it? Notice here we've got the minus on the x and the z. Okay. So remember, here the z had a plus, so it was running along the z-axis. But here in this problem, the y has a plus. So that tells us what? It's going to run along the y-axis. So let's look at this. See if we can kind of sketch this graph out some. All right. So let's look at this. So, for z equals 0, that's going to tell us what? That's going to give us, let's see. Let me erase all this so I can come back up here and do this. So I can see the equation. Z equals 0. So that means negative x squared plus y squared over 4 equals 1. So can you see that this is a hyperbola? Okay, can you see it's a hyperbola? We've got y squared over 4 minus x squared equals 1. That's a hyperbola. The trace is. And what plane is it in? It's in the xy plane. And then what about x equals 0? Well, that's going to give us what? Y squared over 4 minus z squared over 2 equals 1. We can see that's a hyperbola also. And what plane? That's in the YZ plane. And then let's set y equal to k. And so that's going to give us x squared plus z squared over 2. Okay. And yeah, equals k squared over 4 minus 1. Now notice here I didn't let k equal 0, did I? Because what would happen if k was 0? Then I would have all of this is equal to negative 1, right? That's not going to happen. So we know k has to be larger. Okay, k has to be larger than 2. But think about this also. It can also be what? It could be less than negative 2, couldn't it? Because I'm squaring it. So think about it. Think about it. Look, there's 0, there's 2, there's negative 2. Okay, I'm saying that k can be here or here, right? Because if I take negative 3 and square it, I'm going to get 9 over 4, which that's going to give me a positive over here. And same thing here. See, k just has to be larger than 2. Okay, k has to be larger than 2. This isn't going to, we're not going to let it equal 2 because that would give me 1 minus 1 is 0. This is not going to be 0. Well, unless x and z are 0. Okay, but we want k to be larger than 2, and so we want the absolute value of k to be larger than 2. And so let's based on this right here, let's draw it. Okay, so all right, so I've got X, Y, Z. Now when I'm looking at this, I've got, let's see, 1, 2, 1, 2. So I know I'm going to be here or here, right? So think about it. So if K, which Y, if Y is 2 or -2, I'm going to have a point here and here. Now, what do I have? I have hyperbolas, don't I? I have a hyperbola in the XY plane, and I have a hyperbola in the YZ plane. So let's draw them. So let's draw our hyperbola in the, I don't know, maybe the XY plane. So that's just going to look like this, right? Something like this right here. So it'll be something like that. And then that's in the YZ plane. Now let's draw the hyperbola in the XY plane for this one. So that's going to look something like this. And then it's going to, this right here over here would be hidden. And then we've got this over here, be something like that. And then here, this would be hidden. So there's your, in the XY. I hope it kind of looks like it is, but I don't know. And then here we go. There's your ellipse there. I'm gonna erase that a little bit. And this is actually the point 0, 2, 0, and this is the point 0, -2, 0. All right. So that's your graphs right there. And you can see, notice how it differs from this one up here. See, here the Z was positive, but in here the Y was positive. So it's just like you're taking this and just kind of laying it down on that Y axis. So what do you think it would look like if X squared was positive? Well, it would run along this way, wouldn't it? Okay. And once again, let's not leave this one out so we can see what that graph looks like. That's going to look something like that right there. All right, so that's this section, cylinders and quadric surfaces. So hopefully you have a good idea, or you learned how to kind of sketch these things, and hopefully you have learned to identify the traces and identify what plane they're in. Okay. All right, so I'm going to call that a video on this one. I hope you enjoyed it. Hope it didn't put you to sleep. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.